establishing connection to Science Night. Please stand by.
Welcome back to another edition of the Science Night Podcast. My name is James, and with me, as always, is Steffi.
Hey.
And Jason.
Hello.
Tonight, we're talking about
That's
a
a good
very
one.
scary Barbie and some memorable nano-wires. In the second half, we have some thoughts on flexible minds. There's a lot to do, so let's get to it.
Felt very Seinfeld.
That was a good one.
Hello.
Yeah.
That was a good one.
Right.
That woke me up.
Yeah. Our first story may seem like a replay of a past episode. A star is getting pulled into a supermassive black hole and being shredded in a process that we had a lot of fun with before called spaghettification. The difference is this one is called Scary Barbie. And it's also like 1,000 times more energetic, meaning it's currently one of the brightest things in the sky. It's been doing this for 2 years, way longer than other astronomical events of this magnitude, which usually last between weeks to a month. And again, it's called Scary Barbie. So what do we think about this, like, not so dreamy house?
Oh,
Okay,
that was
first-
well done.
Yeah. that's right.
Yeah, that was a good one.
So yeah,
I
like,
also
if
love
a,
the
if
name,
a supermassive
obviously.
black hole isn't getting pulled into it isn't called Scary Barbie, but getting pulled into pulling in a sun, would we even talk about it? That was a mangling of Shakespeare, so got
That
that
was.
going for us.
It was. So is this Scary Barbie just the newest Spice Girl sponsored by Mattel?
Or is it the newest what was the Aqua?
Aqua. Something like that.
I did a cheerleading routine to that in high school. Are
Really?
you talking about the Barbie Girl song?
Yes.
Yes. Oh, yes, we did. Wow. Okay, so it's pretty amazing that they assign, random numerical and alphabetical symbols to these supernova and star names. And then out of this one comes Barbie. Like, if you
Right.
look at the actual name, it's
Yeah.
pretty clever.
So-
So I'm very pleased with the name.
The alphanumeric name is ZTF20ABRBEIE, assigned to reference its frightening power. All you alphanumeric heads out there are going to tell me how that references its frightening power, but that's what it said. That is a direct quote.
It's true.
Yeah.
And the name Barbie is in there, right? And they had to go
Yeah.
with Barbie, not Arby's, because
Mhm.
all Arby's are scary, and this one, not
Yeah.
all Barbies are scary.
Well, and they have the meat, and this is talking about spaghetti. So I don't
Yes.
think the
Yeah.
link is there.
Right.
Yeah.
We
Yeah.
have the pastas. Yeah, it doesn't work.
Yeah.
Okay.
Right.
Should we talk about like a supernova? Because
Yeah,
these are
let's do
just
it.
amazing.
That's the point, right? I mean, yeah.
Right? So they're one of the most luminescent objects in the sky because what they're doing is they're shredding stars. So a supernova, it's basically a really powerful luminous explosion of a star. And it occurs during the last stages of a massive star when a white dwarf is triggered into a runaway nuclear fusion episode. It's just fascinating. Okay, like beyond everything going back to fusion, obviously, and plasmas, when you think about like what's happening inside of these supernovas, and they have this pressure drop, which then triggers gravity to take over and like compress it, and then it can start shredding things. That's just amazing. when you
Right.
can collapse a star in seconds. And that's that collapsing of the star in seconds. That's what comes up with it. That's what triggers that supernova.
It's crazy
So-
though, because that thing burns so bright, right? Scary Barbie is burning so much brighter than anything else. And I
Yeah.
think I read that it happened like 7 billion light years away or something like that,
Yeah.
right?
Yeah.
And so that's a long time, right? Or long distance rather. That was a big mistake, but long distance is what I meant to say. Which means that, it takes a long time for that light to get to us. It's been burning for a while, right? But it happened in
Yeah.
seconds. It's amazing.
Mm-hmm.
Mm-hmm. Yeah.
And it's
Yeah,
also
and then-
like we said it in the last episode, and this story just makes me stand by it. It is like one of the most metal things in science, right?
Oh, yeah.
It is.
That a supermassive black hole is just like shredding a star, like a Steve Vai guitar solo.
Yeah, that's why they call it spaghettifies, because you're just shredding these stars into long strings of plasma, noodle-like shapes.
Mhm.
And then these noodle shapes of hot plasma are accelerating really, really fast around these black holes, and that's what's spinning out those jets of energy and matter, producing that light that you see. So just
Crazy.
like the combination of like beautiful violence, I just love it.
So it's a lot more. So when I think of shredding, right, like the first thing I thought of was the effects that you saw like in the Avengers movies, right, when Thanos snaps his fingers, right, and suddenly boom, people start to just disintegrate, right? That was the first thing. But this is way more powerful than that. It's like if that happened and each one of those
Yeah.
pixels that was moving away like exploded at the same time, right? And generated all this energy. Like I just cannot put my mind around how this happens. Do you have any insight there, Steffi? Like how can you wrap your mind around this? Like I've studied for a long time, deep time. And I know that that's a hard thing for some people to understand, right? Like what's the difference between 1,000 years ago or 50,000 years ago or 50 million years ago or, 4.6 billion years ago? Those are hard things to understand.
Mhm.
This to me, I can understand those. I cannot understand this.
So
Help me
for
understand
me,
how this happens. How do you put your mind around this?
how do I put my mind around this? So part of me works in the mathematical sense, right? Where I like you can see the equations and yeah, you can
You
see how it
can.
happens on paper, right? And through the simulations and things like that. But then when you're extrapolating it to nature, because like you get predictions from these equations that predict these extreme events,
Mhm.
and then we actually can observe them with our telescopes, right? And like I can go in the lab and we have diagnostics to like get these extreme temperatures, and even still you're like, wow, because deep inside, like when it goes into supernova, you're fusing carbon.
Mhm.
Like I'm used to fusing like hydrogen, which only happens like on Earth in like 100, 200 million degrees, but the pressures and like densities and temperatures you need to fuse carbon is just like mind-blowing.
Right.
Wow.
And then you're like,
Right.
we wouldn't be here without that.
Well, right, because
So we are living examples of it.
because the temperatures and pressures to form carbon into diamonds is still mind-blowing, and that happens
Right.
right here, and we can do that in a laboratory. You know what I mean? And it's still
And that's
mind-blowing.
the crystalline structure, right?
Right.
That's not fusing the
Right.
nuclei.
Exactly. Right. So I can't even get my mind around that. Yeah, that's nuts. So when you were describing that, it reminded me of the way that Brian Greene, the scientist who is behind string theory, describes string theory. And it was masterful, Steffi. I really appreciated that. Right.
So
Just
string theory is another one of those things that's just so fascinating.
Right. Right. And it's all about the vibration of
Right?
the universe, right? And
Yes.
like you can, again, he talks about all of these, you can see these equations and you can make predictions. And then when you go and you observe
Yeah.
the results of the experiment, and it, comes out to like within, it matches the predictions to like 7 decimal places. That's
Yeah.
crazy, right?
Right? It's
Yeah.
wild.
I can't even imagine.
Or
That's why I don't do computational biology for a reason. So-
I like to do both the computational side and the experimental, because I do like to mesh the two, because
Yeah,
I
it
think
makes
that's
sense.
super important.
Right. Super powerful. Like a scary Barbie.
Like
Like
a
a
scary
scary
Barbie.
Barbie.
It's just fascinating.
I mean, what you're saying, Steffi, it's just reminding me that we are all stardust, right?
Yeah.
We are golden.
I mean, yes.
That's right.
By the time we got to Woodstock, we're 500,000 strong.
I know. I got the music, right? I already got the music pulled off, ready to go for this episode.
Very good. Very good.
I can't believe I went Steve Vai and not Eddie Van Halen. What am I thinking?
I know. I mean, Steve Vai does shred. I agree. But if we're talking shredding,
right?
Like when you're talking about metal, I don't think Steve Vai fits in that, right? If you're talking about shredding, we got to be talking about like Dave Mustaine.
Yeah, but he's such a prick.
I mean, right. You got to separate the art from the artist.
I know. Kirk Hammett.
Also a prick.
Yeah. Actually, James Hetfield's more of the shredder.
Actually, you're right. And also James Hetfield is more of the prick. Kirk Hammett is not.
Yeah, Kirk Hammett is just happy to be there.
That's right. I'm sorry, Kirk. I did not mean to say that.
Kirk, come on the podcast. You like science?
Brian May.
And he's probably a listener.
Let's get Brian May on here. He is a scientist, he shreds, and he's an astrophysicist.
Are we having a shredder episode?
We should.
Yes.
Okay, we can get all different aspects of shredding.
Oh my God, Steph, you're a gosh dang genius. I don't even have to bleep that. Mail that to ourselves when we
You might want to bleep that just because it was kind of embarrassing.
No, I'm gonna keep it in. But hey, all you other science podcasts are listening to us, don't steal this. If I see Luxi come out with like, hey, this is the science of real fancy guitars, I'm gonna be real angry.
Me too, but I'm a totally high five Luxi first. Then I'll be angry.
Sure, fine.
Yeah. Whatever. And if you're a scientist that you do a lot of shredding, just
Also, Luxi, if you want to like fly us out to Greece to collab, just send me an email. Let's go to Athens, guys.
Okay, I'm up for it.
Anywho,
sure.
I don't know how much of that I'm going to keep, if anything.
That's okay.
I think the fun stuff
We're just riffing, James.
Yeah, that stuff is fun. I like listening to that stuff.
It's all going in the YouTube thing, but yeah, that's our A to B. I've been doing less editing on the YouTube front to see if people like that better. Just like weird astronomical phenomena, we also talk a lot about things that can be implemented by our future overlords, the Xenobots, to quicken the impending downfall of humanity. This time, a team from Sydney taught a network of nano-wires to act like a human brain, even created short and long-term system memory. Basically, researchers created a circuit, guided the nano-wires with a series of impulses, and found that the wire remembered the circuit after about 7 repetitions. And over time, with enough reinforcement, made a permanent connection, which is kind of how the brain works. So now we have a nano machine brain, but they still never stop to ask if they should. And that's the intro.
I love that quote. I use
it
so many times in serious meetings, and then there'll be that one person that gets the reference and they'll just lose it and no one knows what's happening.
Yeah, I know. People at the Luxi podcast are losing their minds over that reference. I know they're the cool ones, right? They're auto downloaders. I don't know why I'm just going back.
People?
She was on her podcast. It was you weren't on that episode.
Yeah.
Oh,
yeah.
That's right. You were doing like cool kid stuff or something.
I think she was at the White House or something.
Yeah. God, that old thing. So let's talk about these nanowires, right? It's kind of cool that they basically hey, we can make electricity work like the brain. Sure, nothing will go wrong with that, right?
I find it fascinating. Yeah, first of all, it's awesome that they're able to do this. I think that there are a lot of implications for having machine learning that can do this, especially in the age of AI now, right? Where we might be able to have some real human-like artificial intelligence instead of completely artificial intelligence. I worry about where that's going to take us, but that's a different episode altogether.
It's a movie called Megan.
Right. Yes, it is. But here's the thing that baffles me, and that is that we don't understand still how the brain works very well. And, we have a better idea than we did, yet even the simplest modeling of circuitry here, and maybe that's not fair to call it simple because it's not simple, but it is a simple schematic compared to the neural networks in the brain. They're able to replicate human-like thinking. And that to me is crazy, right? Because it's so much more complex than this model, yet this model got it pretty well, it got it right.
It's like the first steps, right?
Right.
So, from this, maybe you do get something that actually works more like the human brain, where you have all these impulses from everywhere, and it's like a constantly dynamic and evolving situation.
Right.
Right.
So
like,
I think the key here, though, is that this is modeling behavior that happens in the prefrontal cortex, right? This is, and that's, that's one of the things that that primates especially have developed quite a bit compared to other species. So this is more human-like thinking than, say, what you would find in a crocodile, right? Or in a shark or in a mouse. But some of the decision making that they're modeling here still has to happen with these other animals. And so my question is whether or not we're accurately saying that this is human-like thinking, or whether this is just, how a brain has evolved to work at the very basic level, and the human aspect of it, the expansion of the prefrontal cortex, right? That is going to involve a lot more complicated circuitry. And maybe this doesn't model that very well, even though maybe the basic human thinking pattern is just like what happens in other species.
Yeah, I think starting here in the early steps and then seeing where it goes from there, that's pretty fascinating to just make it to this where they show the short-term and long-term memory difference too, right? When they did these experiments.
Mm-hmm.
I'm thinking too, just like kind of reversing and using this like mechanical experiment to kind of teach the basics of neuroscience to people too, right?
Yeah, that's a great point.
Yeah.
It's I'm gonna like air out my downfalls here. Like neurophobia is something that lives and burns bright in my heart. I love teaching anatomy in my anatomy lab. When we get to neuro, I do just kind of turn my lights on and hide in my office until the class is over. I gave it the old college try. I'm trying to get there, but it is tough for me. And I think a lot of it is because you really can't visualize it that well.
Yeah.
You can try, but it's really tough for me to kind of like
I totally agree
it.
with you. I have focused most of my career on teaching the gross anatomy of the brain. And there, I don't teach neuroanatomy. I've never actually taken a formal course in neuroanatomy. I learned it all on my own. But there's a very big difference between neuroanatomy and neuroscience.
Sure.
And neuroscience is really what this is talking about. And unfortunately, that, to your point, James, is what neuroanatomy coursework has become in order to meet the needs of the learners, right? It has become more of a neuroscience approach in the context of anatomy, as opposed to a neuroanatomical approach in the context of neuroscience. And so I say that because neuroanatomy is not an experimental discipline, right? It is a strict point and describe kind of discipline, right? We're not, neuroanatomists are not trying to understand circuitry. They are trying to describe it in a manageable way so that people who are interested in how to understand that circuitry, or even push that circuitry to change in some way, have the tool set that they need to do that, right? And so I'm with you. I have neurophobia because it has moved so far afield from neuroanatomy into neuroscience that I am not equipped. Even as a PhD in anatomy and as someone who has been teaching gross anatomy for over 20 years at the highest levels, right? Still, I have neurophobia too.
Yeah.
I mean, this is fascinating to me because I don't really know anatomy. What I know, I learned from you all. Okay.
Oh,
So
boy.
it's like
I'm
foreign
so
to
sorry.
me.
I'll cut
But
that part
the
out.
fact that, no, it's fine. Um, but the fact that, we can only learn so much from human brains, and like that's like a scary thing to go in and manipulate a human brain and learn about things like that, right? When you're trying to help people and understand. And the fact that you have this experiment now of nanowires that you can manipulate that, and you don't have to worry about like real life implications of people.
Until that neural network decides that it
my
has
gosh.
learned your behavior and now
Yeah.
it controls you, right? And that's when you have
And
to
it's
worry about the
called
implications.
Megan.
That's right.
And is taken over by tiny little xenobots. It's over.
But we're not there yet. So what? We have like 3 months.
All right.
weeks.
Question for both of you. Would you rather be overtaken by xenobots or subjected
Shredded?
to spaghettification?
Spaghettification.
I
'Cause I
really
feel
need
like
to see
that
their
would
policy
be-
standpoints. Like, where do they stand on the climate crisis?
Yeah, that's fair. That's fair.
Well, how much of the supernova can I see before I've spaghettified? Because I feel like even a brief second, if I get to see that before I'm like shredded and turned into a star, versus like a
Ooh.
slow and long-lived. And is it like when the xenobots are taking me over, am I still conscious and aware?
So here's the science communication moment. How long would it take for you to be shredded? And then how long would it take for the impulse from your senses to get to the part of the brain that is processing it? And is one time shorter than the other one? And that's the real question.
Both of the time, I can tell you right now, both of those times are longer than the time it took me to realize I could not answer that question.
Right. I'm just glad we're talking about it. I'm just glad someone's finally talking about it. Well, how about we move from these pesky nano brains and talk about some human brains? But first, a message from a podcast that I think you'll enjoy.
Hello, Science Night listeners. My name is Mark, and I host the Podfulness Podcast. Podfulness is where you go when you want to find new podcasts to add into your rotation. Each week, I bring on a guest who talks about their favorite show and why they love it. Plus, we end each episode with some fun and games. Episodes are half as long as most other podcasts, but twice as joyful. If you're looking for podcast recommendations from podcast superfans, give us a listen. Just search for Podfulness on your favorite streaming platform.
Podfulness.
Welcome back. In the first half, we talked about a nanowire brain, but now we're going to move on to humans. And we talked about some neuroscience-y, jargony type things like prefrontal cortex, and I guess we use the word human. So let's explain them a little bit. But first, the thing you need to know is our world is constantly changing, but you never really stop to think about how your brain learns new ways of doing something to cope with this change. A team at UCSF recently looked into this phenomena using mice, so it's part of my nightmare scenario. They found that the presence of changes in special cells called inhibitory neurons blocked unneeded reminders from moving between the left and the right prefrontal cortex, which is basically the part of the brain that's like right above our eyes. And it's involved with something called executive function, which means it helps us make decisions and stuff like that. And it also deals with new information relating to the changing environment. So why don't we talk about these flexible brains and how the flexible mind is better able to cope with a changing environment? And that is not a quote, but I think they should use it.
I agree with you.
I just think of like, okay, I'm going to use Battlestar as an example.
Do it.
So she can navigate. Battlestar, if you don't know, is a dog. Okay, a Shetland sheepdog that lives with me. She is fascinating because she can navigate at high speed a dog agility course where I'm directing her. So and they're always changing, and so she's adapting to that. But then we go on a walk and there's a stump where a stump wasn't before, and she's just stopping and barking.
Yeah, I get it. And her prefrontal cortex is not as well developed as the prefrontal cortex in a human, for example, right? So here we are back to this discussion about whether the circuitry was modeling, like vertebrate or mammalian behavior, and not necessarily executive function in a human versus a human, right? And so to your point, Steffi, right? I have 2 teenage children right now, and they don't have well-developed prefrontal cortex.
They also stop in front of stumps all the time.
Exactly. They stop and like when there is something put in their way that like they were not ready to navigate or negotiate, like it drives them crazy, right? And they cannot figure it out, and they lose all ability to self-regulate emotion and all sorts of stuff, right? And so, I love my kids, but I also love seeing science happen. So I go out of my way to put those things, the stumbling blocks in front of them just to see how they react, right? And I'm sure that I am not as bad as Margaret Mead was. So I just want to be clear.
I was gonna say,
I'm not scarring my children. I am just entertaining myself.
When's the last time you took your IRB training, Jason?
That's right. Well, it's interesting because Steffi referred to Battlestar as a dog that lives with her, and I talk about my kids as if I own them. So they're very different.
Primates that live with you.
Right. I'm a caretaker of Battlestar, and she knows it.
Mm-hmm.
Nice.
I want to talk about Battlestar too, because what really made the difference is that the Vipers were way more flexible in their tactics, and there's the deep cut, right? And Starbuck was such a good leader.
Yeah. Mm-hmm. Now we're talking about
Katie
Galactica,
Sackhoff's an American treasure. There, I said
not
it.
Deem. We're talking about Battlestar Galactica, not Battlestar Deem.
Yes. Yeah. So bark we all.
I'm not going to need a stinger for like 3 months.
Was the dorkiest thing I have ever heard you say, Steph.
And by the way, like
that's on her competitive like dog agility harness. It says Battlestar on one side, and then the other side it says it's embroidered in like glitter thread.
Of course.
So bark we all.
I throw a picture of Starbuck through the Canva filter and make So Bark We All merch with a Science Night patch on the side. Can I have your blessing for that? I will donate 100% of the proceeds to wherever you'd like.
Yes. No, 100% of those proceeds need to go toward Battlestar's competitions.
Yeah.
Sure. Yeah. Done.
Snacks.
Unless we make like $1 million, but
No, I still think they need to go to Battlestar. We didn't do this without Battlestar. Battlestar lives with Steffi, right? If this was my kids, it would come to me. So we're good.
Can I get a picture of both of your kids and put a stump in front of them and just like puzzled looks, and we can see which sells better?
I think no, because I think my wife will put a stump in front of that. Right? Say nope, not gonna happen.
Jason, you're not allowed to play with those kids anymore.
Yeah, sounds about right.
So this article, huh?
Yeah, I found this to be fascinating. What I found most fascinating was that they were able to train these mice to make decisions, and then they could inhibit them from being able to realize changes later by changing sort of the approach to blocking some of that circuitry.
Mm-hmm.
And it really made these mice like incapacitated to make decisions here. But what is interesting is that they were able to model through this how, when we need to make new decisions because we have new information, the brain actually will sort of tamp down that circuitry that tells us to remember something for enough time so that we can make the new connection, make that new decision, right? And then it imprints that instead, which I thought was fascinating.
Right. That took me like a couple times to read through that section to really get it. Like, I don't know, for some reason I just think of the brain. I think of the brain working a little bit more elegantly, but really it's just like the part of it is still screaming out, hey, you need to go this way. Hey, you need to go this way. But the brain's like, you shut up for a second.
That's exactly what it was, right?
It's wild.
Which I thought it was just me that has parts of my brain screaming at other parts of my brain to shut up. But I guess it's everyone, right? I mean, I really thought it was just me, like that my neuroses or whatever. But nope. I guess that's the way executive function works.
And the other thing I really liked is they are basically proving how neuroplasticity works by showing that they can map out this circuitry, inhibit it, and then show that in the behavior, but then also reestablish impulses experimentally in the same mouse and have them able to relearn the maze that they're going through.
Yeah, it was amazing.
That's
It's
amazing.
This story, it was just really
Wow.
interesting. But back to our point earlier, the moment I started reading it, I started getting that neurophobia, right? Like I should be understanding this way better than I do, and I don't. It took me a few times to get through it as well to figure out, what are they actually saying? Now, part of that may have been that it wasn't actually written for the public very well, even though it was written in a very public venue. I think it was The Conversation for this one, yeah?
Mm-hmm. Yep.
And so it should have been for a general audience, a general, literate, educated audience, but nevertheless, but still not an audience that has the same jargon that they do. And yet it was full of jargon and not good definitions of what that jargon was before it moved on. And so that was a little frustrating to me as someone who's, in a field adjacent to neuroscience. I still had trouble understanding what it was they were saying.
Yeah. And I think also like what they were saying without saying, and I wish maybe they were saying it a little bit louder, is they were talking about changing worlds, right? They were saying like the people that are able to kind of use this ability are going to be able to navigate a changing world better. They showed it in mice. They made the jump and say like it works this way in humans too. And what they weren't saying is that climate change is changing the world.
Like jobs I've done where I was like a contractor at a national lab where I had to work on like 5 different projects at once. And that was straight out of grad school, going from 1 to 5. And you're thrown at like so many different directions, and you have to be more flexible to what you're working on and adapting to. And that translated to like how I can do different jobs all at the same time. And people are like, how are you able to do this? And so, yeah, with climate change, we're going to have all these disasters kind of happening at once, and people are going to have to adapt to that.
Yeah.
That's a really good point. And I think it extends further than just the individual having to do all of these things at once, but the perspective that we need to be considering, how do we move forward on action as a result of climate change is going to involve so many different parts of a discussion that we don't really consider too much right now. Like we talk a lot on this podcast about the scientific implications of climate change and how that's affecting things like, ocean temperatures and weather disasters and things like that. What we're not really considering here are the social science implications. Now, we actually tend to discuss them a little bit more than other places do because James and I have a background in anthropology, and so we're already thinking that way a little bit. But decisions about how to move forward or how to deal with climate change need to take into consideration the basic science, but also the social science, because we're talking about people needing to, to respond to climate change, not just ecosystems. And people are part of ecosystems, but because we are so flexible, right? I mean, we are one of the hallmarks of our species is our ability to adapt to any environment. That's what has made us so successful over our evolutionary history, is that we can change and deal with changes put in front of us. That's amazing. But when we don't consider the social science implications, right? And when I say social science implications, I'm talking about things like economics, right? Economics are important implications here for how do we deal with climate change, right? I don't know that I agree 100% of the time with what economists say, but they're not wrong when they say that, if we have melting sea ice in the Arctic, that will open up new shipping routes that are going to actually connect communities differently than they have been connected before. And even though there may be problems elsewhere in the world, these problems or these new opportunities are something that should be considered when we talk about how do we account for our response to climate change, right? I think though the one thing that we can all agree on for sure is that we're not responding fast enough to the changes that are happening too fast for us right now. And that, regardless of who we are listening to when we make policy decisions to deal with it or not deal with it, as is the case in many of the situations. We're not doing it fast enough regardless.
Yeah. And who
That
are getting
reminds
input
me
from?
of, sorry.
No, that's fine.
That reminds me of Steffi, your interview with Devyani Singh, where she was talking about a just transition, not just being like hyper focused on net zero, but realizing that there are humans that are doing logging and oil drilling and mining, and that we need and the fact that we can see that there is going to be an end to these industries. It's not like something where you didn't realize that something was going to collapse. We know that there's going to be an end to these industries. So while we're working on net zero and all of these things with scientific advancement, we should also be having this social wing that is retraining and changing curricula and maybe not pushing people to these industries that are not going to have a very long lifespan in the future that is coming. So
Right.
Yeah.
Like, for example, here in my state of Indiana, right, there's a push. People really want electric vehicles, right, for good reasons, right? But anybody who has an electric vehicle in the state of Indiana and charges their electric vehicle in the state of Indiana is doing it based on coal energy, right?
Yeah.
And so we
Yeah.
need to actually fix the front end of the problem as well as the back end of the problem, and we're not doing that.
Yeah.
Right. So your point is
it's
very good.
It's this going back to the life cycle, like the whole impact of a system or an energy system that you're deploying. It's just not just impacting the people locally that are benefiting from, electricity. It's those who are being harmed in like the mining process and all the other processes too, and the job implications too.
Right. I mean, one of your senators just this week, Steffi, was arguing about climate change on the floor of the Senate. I don't know if you saw this, and
No.
it was in a hearing actually. So it wasn't the floor of the Senate, but it was in one of the hearing rooms, and it was I don't remember exactly what the context was, but he was berating someone who was showing that climate change was going to impact places closer to the equator much more than the state of Wisconsin, which actually was going to benefit from climate change because there will be fewer cold days. And the argument was more people die because of too hot days than too cold days. Right. Sorry, other way around. More people die from too cold days than too hot days. Right. And so even though there will be more hot days closer to the equator that actually might end up really harming people, the people of Wisconsin were going to be better off because there were going to be fewer cold days. And that was actually going to be more of a benefit than the detriment of too many hot days close to the equator, right? And it was just the most like backward, right, asinine kind of argument that,
such garbage.
It was I could not even believe I was hearing this come from someone's mouth at the highest levels of government in 2023.
Yeah. Well, and if you take the next step, you'll see that people who are also making that argument are very unlikely to let the people from the equatorial areas that are getting super affected into the area where there is a benefit, right? Like,
also true.
They're just not going to let that movement
100%.
happen.
Yeah.
Well, right. Because then other problems will be caused, right? So here we are talking about the people implications, the social science implications of climate change being completely disregarded in favor of only the scientific, yet this time from the side that we don't typically see it coming from, right? And it
I've
boggles the mind.
I've been doing some work in this, like looking at the socio-technical aspects of developing fusion energy and, centering equity and environmental justice.
Of course.
And the pushback I get from people when they first hear about it, like I've gotten, that's not technical. I'm like, are you kidding me? Social science is science. Like,
right.
The communities you're impacting are real people with expertise that we are not listening to.
Right. It's crazy. Well,
how do you think we got to where we got now?
So I will say this, Steph. I am grateful that you are working in this area. I really am. And if there's anything that I can do, or I'm going to speak for James too, that James can do, like, let us know. We will help you, because to me, that's the single greatest, most important aspect of response to climate change is dealing with the people who are involved. Right.
Yeah.
I mean, and I I don't want to say it, but I'm kind of a celebrity right now. I mean, we should use this heat.
I love it.
That's true. He is kind of a celebrity.
Like, I want to toot my own horn. But I don't know. Hearing the two of you talk and thinking about this neuroflexibility article, thinking about human evolution, hominid evolution, and what got us to this point, and knowing that in our lineage, there is the story of flexibility, adaptability, working together, social organizations that can get us as a species through very hard times. But we've developed to a point where it seems like we forget that we can work together to get through hard times. And we got to remember that part too. Hey, it's like if Lee Berger was also Mr. Rogers, right? That's me right now. I'm putting on tennis shoes, getting stuck in a cave.
I could just imagine Lee coming in to the cave, taking off his fedora and putting on his cardigan.
Lee, I will make a t-shirt for you if you send us that video that we can use for an intro. I know you're listening, Lee. But the other point, go ahead, Steffi.
No, I like the visual.
Just like, does anyone have anything at the end? Because I just wanted to maybe ride out on a point.
Let's ride out. Let's do it.
So I guess maybe the last point I wanted to make is, Jason, you talked about how we're so focused on ecosystems and how ecosystems are affected by climate change and not social systems that are affected by climate change. And I think the thing that we all need to remember is that eventually the ecosystems are gonna be there. We just might not be in them.
Mm-hmm.
That is the thing that we need
Yep.
to remember with climate change.
Right.
Like,
The Earth
the
will be
Earth
okay.
will be fine. This is a drop in the bucket for the Earth. But there is also a long lineage of species from our legacy that aren't around so much because of climate change.
Right. I mean, there's no question that we have left an indelible mark on this planet, right? In terms of the number of species that we have caused to go extinct, whether because we have hunted them to extinction or because we have polluted their environment so much that they are now extinct or can't reproduce because of that. We've left an indelible mark.
Mm-hmm.
But it's an indelible mark during our time period, right? I mean, it can get erased in some way, right? With new evolution of species that will happen once we're long gone from this planet. So, I think I've said it before. We are really fortunate when you look at the longevity of mammalian species in the fossil record. Like, we are one of the longer, sustained species. That's nuts to think. So maybe we've overstayed our welcome, right? I mean, the Earth is telling us that we're not treating it well. We should listen, but we're not listening well enough.
Yeah.
And so I hate to say it. I hate to be that guy. Although I've been that guy for a lot of episodes, right? We are going to cause our own doom. And so climate change is not just a threat to our way of life. It's a threat to our existence on the planet. And we need to adapt, right? We need to respond. Actually, I don't think adaptation is what we need to do at this point.
Yeah.
I think what we need to adapt our behaviors, not our morphologies, right? Not our anatomy, not our way of surviving, just our way of living.
I think what you're saying, Jason, is all of this has happened before. All of this will happen again. Dun, dun,
Yes.
dun, dun, dun.
Yep, that's it.
That's it. Let's do an outro. We're not going to get better than that.
So good.
Should I put 6 in there saying that?
Yeah.
I think.
Yeah, for sure.
Yeah.
You've made it to the end of No, I don't like that. That's too exciting. You've made it to the end of another episode, but don't worry. We got more coming your way, so make sure to... But don't worry, we got more coming your way, so make sure to follow us on social media. I'm on Twitter at James_Reed3, which that account has just become a Howie Roseman appreciation account. So go and look at me saying how great the Eagles GM is doing. Steffi, where can everybody find you?
I mean, I'm still on Twitter at Steffi Deem. I don't know what's going on Twitter. Seems kind of questionable choice right now. I'm still on Instagram though at Starshippin'.
Yeah, you can follow us all on Twitter as we watch, just like everything Elon Musk touches, the world burn down around him. Jason, where can we find you?
You can also find me on Twitter, at least for now, at OregonJM. I have to tell you, Kathy Ireland, the supermodel, follows me on Twitter. And if I had told 12-year-old Jason that Kathy Ireland would follow him on Twitter, it would be the most exciting thing in the world. And, 46-year-old Jason's just like, oh, another Twitter follower, which is really sad.
Man, what is your life? What is the world when we have former supermodels that are following science communicators? And also, like, Kathy, I'm really charming on Twitter.
I want MC Hammer to follow me.
Mm-hmm.
He's been following a lot of scientists, so.
Oh, we can the secret this. Just throw it out into the universe, right?
Yeah.
Yeah. It's true.
Well, MC Hammer, if you also want to follow the show, you can do that at SciNightPod. Also, Kathy Ireland, you can follow the show too. We'd love to have you on our Twitter. All you got to do,
Kathy, is click on my link. There's a link in my bio.
There you go. You can see that at SciNightPod, and you can also visit our home on the web, sciNight.com, for links to all our other social media, including our YouTube page, which got the entirety of Season 3 up and ready for you to watch. Past episodes, the people we talk to, the stories we talk about, and our merch. And there's definitely going to be some Battlestar merch coming out soon. Keep an eye out for that. There's a lot to see, and you can see it all at sciNight.com. We will be back in 2 weeks with a new episode, but until then, follow us, Kathy Ireland.